All right. You guys so?
All right, everybody say hi, 8th period.
She likes it better. Way better.
They're so boring. They're so boring. All right, whatever. Anyway, okay, complex numbers. All right, so we're going to get a bit off of quadratic topic just for today and talk about complex numbers. And then tomorrow, not tomorrow, like next week, I'll show you how complex numbers relates to quadratic functions, okay? Because it's superly important. Complex numbers, this is all arithmetic stuff today. Not even algebra, really. All arithmetic stuff. So adding, subtracting, multiplying, dividing, taking square roots, all of this computational stuff, okay? People try to do these with their calculators, and your calculator will lie to you. It will give you the wrong answer, okay? So don't do these with a calculator, because when you put into your calculator the square root of negative 27, it will say error, and it will not be able to do it for you. So don't try. They're still going to try. They're getting their calculators out, 8th period. They're still going to try, but it's going to give you an error. It's going to say that it doesn't like you very much, okay? So we have to figure out what these are, and really, complex numbers are not terribly hard. There is a lot of complex numbers on the ACT and on math testing stuff, and it involves the variable I, okay? So, and it's called an imaginary number. So complex numbers are imaginary numbers. So like we have real numbers, like non-fake numbers, and now we have like fake numbers. So they have to give us fake numbers. It's like as if math wasn't hard enough, right? Okay, so they give us imaginary numbers. Now, here are two things that you do need to memorize. Two things that you do need to memorize. You need to memorize what I represents. I is the square root of a negative 1. Now, that is imaginary. That's a fake number, because can you take the square root of a negative number?
No.
No, that's why it's an imaginary number. So they call it I. They call I the square root of negative 1, yeah? So now, if I take I is the square root of negative 1, and let's say I square both sides, right? So I'm going to take, and I'm going to square both sides. I squared would be the square root of negative 1 squared. Well, what happens to that? Well, kind of.
Well, you
not really.
Get rid of the bracket.
The square root and the square cross each other off, so I squared is just negative 1. That's where this piece comes from, that top one, right? If you square both sides, the square root goes away, and I squared is the same thing as negative 1. Okay, so we'll get to that, all right? So, starting out with, they want us just to simplify these negative numbers, all right? Just simplify negative numbers. Here we go. For part A, this guy right here, I'm going to break this piece down, and I don't like the negative that's associated with the 27. So I'm going to remove the negative away from the 27. I'm going to call this the square root of negative 1 times the square root of 27. Okay? I'm removing the negative 1 off of it because that's the part that I have a problem with, right? So negative 1 times 27 will give me negative 27. If I put those back together, it still works, right? Okay? But now we know that the square root of negative 1 is what? This guy can be replaced with I, right? That guy can be replaced with I, and the square root of 27, I just need to break him down now. Does the square root of 27 come out nicely? Is it something squared?
No.
Like 5 squared is 25? No, the square root of 27 doesn't come out nicely. So what we do to simplify him is the square root of 27. Have we done this before? No? Are you kidding me? Oh my gosh. Oh my gosh. So we have to break him down. The square root of 27. What can I take the square root of that goes into 27? What goes into 27 and I can take the perfect square root of? 9. So what I do is I separate this guy out into 9 and 3, right? The square root of 9 times the square root of 3 will make the square root of 27. Agreed? If I multiply those together, the square root of 9 and the square root of 3 makes the square root of 27. But what is the square root of 3? Or what is the square root of 9?
3.
3. The square root of 9 is 3, and the square root of 3 here doesn't come out nicely. So this 9 comes down as 3, and this square root of 3 comes down as the square root of 3. Does that make sense?
No.
So we broke the 27 down into 9 and 3, and the square root of 9 is 3, and the square root of 3 doesn't come out, right? So it just leaves it as the square root of 3. You see that? No? You're kidding me. Okay, so we'll do this one, and then we'll do another one, okay? combine the I and the 3 square roots of 3. I and 3 square roots of 3. So I just usually write this as 3I times the square root of 3. That's how I'll write him. I usually write the I in the middle. Whoop. Hold on, I'm delayed. There we go. 3I square root of 3. 3I square root of 3. Okay. All right, let's do one more to practice off to the side over here. I'll leave off the I. Okay, so let's just do the square root of 50 just to practice. Square root of 50 just to practice. What goes into 50 that I can take the perfect square root of? 25 and 2, he says. So I want to put 25 in the circle because 25 is the special number, right? 25 is the special number. So the square root of 25 and the square root of 2 will make the square root of 50 when I put them together. Agreed? Yes? Okay, now I want to simplify those. What is the square root of 25? What does he come down as? He comes down as 5. What does the square root of 2 come down as?
2.
Just the square root of 2 because he does not come out nice. Does that make sense? That's how we simplify each one of these, right? So, if this was, so you're saying if this is negative 50 in the inside here, it would be 5I square root of 2. If it was negative 50, sorry. If it's not negative, we don't care about an I, right? Okay. So I was just showing you how the 50 works. But if it was negative 50, it would be 5I square root of 2. Does that make sense?
Square root, that doesn't even make any sense. 5 square root of 2 equals square root of 50.
Yes, you're right. 5 square root of 2. Yep.
Oh.
Yep. Yeah. Yeah. It does. It does. All right. So the square. I'm running out of room here already.
So then what's I?
I is the square root of a negative 1.
So you're saying that 3 times the square root of negative 1 times the square root of 3 is going to equal
This is negative 27. Yes.
Really? But how do you know what the square root of negative 1 is?
You can't take the square root of negative 1.
No, then how does it go back into the equation?
Okay. So if you want to work in reverse. Oh, Marcus. Why do you have to do this? So he says, you mean to tell me that this guy becomes the square root of negative 27. He's not seeing how this works. Okay, Marcus, I'm going to put it back together for you. Just think about it this way, okay? We said I was the square root of negative 1, right? So I'm gonna delete that out, and I'm going to put the square root of negative 1, right? Okay? So if I multiply the square root of negative 1 and the square root of 3 together, this will be like 3 square roots of negative 3, right? You buy that? If I multiply, no, just wait. You buy that? Negative 1 times 3 is negative 3. Okay? Now, just wait. Just wait. Now, just wait. If I want to take the 3 and I want to stuff him back inside of there. If I want to take this 3 and I want to stuff him back inside of here, he actually has to be 9, right? Because the square root of 9 comes out as 3, so if I want to put him back, I have to square him to put him back inside of it, right? You see that?
Okay.
Okay, so this is the square root of 9 times negative 3. Well, what is 9 times negative 3?
But the part I don't understand is go up.
What? There is no up. What's up?
Move it, the paper
Okay,
down.
okay, there you go. What?
When you take the square root of negative 1 and the square root of 3, you don't
You're
know what
multiplying
the
them
square
together.
root of negative 1 is and the square root of 3 are.
So if I just gave you the problem,
Like,
That's why you leave it as a square root. I see what you're saying. It does not come out as a nice number. That's why you leave it as a square root. I don't want to simplify it as a decimal because I want to leave it as a square root.
so you don't, like, with those, you don't have to, like, break them down even more.
No.
There's nothing that
No. Right.
wait, but if I gave you
Okay.
the problem
What?
4I square root of 2, you'd be able to figure it out?
Yes.
So what is it?
I guess
4I square root of 2 would be the square root of negative 32.
Hi.
Okay,
So,
but like
Find out.
I'll show you later. We're recording. I don't want to waste time. I'll show you later. All right. What?
But what if it comes out like even?
Then you just write the number and you don't put a
So
square root
like
after it.
the number
Yes.
I-
Correct. Yes.
Yeah.
Okay. So this guy, I have a problem with the negative. I don't like the negative on the front of the 216. So I'm going to pull off the negative. So this is the square root of negative 1 and the square root of 216 because those two multiplied together will give me 216 again, negative 216 again, okay? So, but negative 1 I know is I, right? This guy is I. Now I just have to break down 216. Okay, and I don't know what this is broken down. This is a big number. What can I break this guy down as? Think of a number that goes in 216. Like, does 4 go in there?
216. 1.
But you can't take the square root of 12. So you can't take the square root of 18. What?
1.
Well, does 4 go into it?
Yes.
216 divided by 4. What's that? 54.
Yeah.
No.
But then 9 goes into that. Ooh, I got a big number. You ready? 36. 216. 36 goes into it. You betcha. 36 and what? 36 and 6? Yes. Can you take the perfect square root of 36? You betcha. Can he take the square root of 6? No. So this guy, if I take the square root of 36, he will pop down as 6, and this guy will be the square root of 6. So if I combine that all together, and I want to know what the square root of negative 216, 6i times the square root of 6, and that's what he will look like. Yes? Yes? Yes, 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 yes.
I'm gonna use this so
What am
much.
I-
You are really going to use this a lot. You really are. You just don't know what you're going to use it for yet.
I can't wait to use this while I'm doing taxes.
You're gonna be fine. All right, here's the deal. Okay, the next one. I know, whatever. All right, here we go. So A, simplify. Products of pure imaginary numbers. Okay, this one's not bad. So negative 5i times 3i.
Negative 15i.
Negative 15i squared, right?
Is that actually right?
Almost, yeah. That's actually right. Negative 5 times 3 is negative 15. I times I is I squared. Yes. Now, what is I squared equal to?
-1.
This guy is actually equal to negative 1. Okay? All right, now what? So, negative 15 times negative 1? 15. Done.
Wait, what am I? So if I see that, can I put it in?
Sure.
Oh wait, no,
Show
I
it. Sure.
So you,
I get this one, but I don't get
okay, so on this
Okay.
one, the I squared
All right.
is negative 1.
So, on B, just wait. On B,
this. Oh no.
I have 2 pieces, and I want to break both of them down. Okay, so this 16, or the square root of negative 6, I'm going to start with the square root of negative 1 and the square root of 6, right? Okay. Now, the square root of 6, can I break him down? Is there something that goes into 6 that I can take the perfect square root of? No. So I'm just going to leave him as the square root of 6. So this guy will be written as I times the square root of 6. Because 6 does not break down further, right? Okay, I square roots of 6, okay? Times the square root of negative 15. I'm going to break him down over here in blue. So I want to hang off a negative 1. Okay.
Negative one.
Square root of negative 1 is I. Okay. Now, the square root of negative 1 is I. Okay, the square root of 15. Can you break down the square root of 15?
No.
Like, does 15 break down
No.
smaller?
No. So it's just I.
So this guy is just I times the square root of 15.
It's hard to do that.
Okay? The negatives go away with the i's. Just wait a second. Okay?
Alright, I squared.
Okay? So, now I have this piece times this piece. Alright?
It's I squared.
So,
times.
I squared, and the square root of, what's 6 times 15?
That is 90.
90.
So
I squared times 90. The square root of 90. Okay, just wait. We got to see if he can simplify anymore. I squared, can he simplify?
Yep.
This guy is negative 1. Okay, the square root of 90, can he break down? The square root of 90.
Jason. No. 30 times? Oh my gosh. No.
What goes into 90 that you can take? Listen, what goes into 90 that you can take the perfect square root of? 9 and 10, he said. Can he take the square root of 9? Yes. Yes, he's a perfect square, right? Because the first one is the one that you can take the square root of, right? Yeah. I always put the 1 in the circle. Yep. So the square root of 9 and the square root of 10, that's what I have. Okay? The square root of 9 comes down as 3. The square root of 10 stays square root of 10. Okay? Now, here's the deal. Almost done? Almost done? This is negative 1 and 3 square roots of 10. So does it become negative 13 square roots of 10?
No.
No, this is multiply. Negative 1 times 3 square roots of 10. What does that make? This guy times this guy. It just becomes the whole thing negative. Negative 3 square roots of 10. Right? Negative 3 times negative 1 is negative, or 3 times negative 1 is negative 3, right? And it's negative 3 square roots of 10. Okay, now, this is totally why this is important. Oh my gosh, this is totally why this is important, right here. This is where imaginary numbers come into play, this next example, all right? X squared plus 64. This is a quadratic function, right? X squared plus 64, this is a quadratic function, okay? This guy is going to look like this. He's a smiley face, right? And like all the way up at 30 or up at 64, right? He's like up really high at 64, all the way up there. And he's going to be a smiley face. So if I'm trying to find his zeros, what's going to happen? If I'm trying to find his zeros, like where he's crossing this thing, there's going to be no solution, right? But when I do the algebra, I have to get an answer. Okay, so here's what happens. If I take x squared plus 64 equals 0, and I'm trying to solve for x, minus the 64 over. Okay, so x squared equals negative 64. All right, now here's the deal. If I take the square root of negative 64, x equals, to get rid of the square on the x, I take the square root. Okay? So let's look at 64. He's negative 1, the square root of negative 1, and the square root of 64. Right? The square root of negative 1, the square root of 64. What is the square root of negative 1? I. And what's the square root of 64? 8. That one comes out nicely. He's not like the square root of anything. The square root of 64 is weird. Okay? Now, in this case, I flip the I and the 8 around. Right? So it makes more sense to say 8I than it does I8. Right?
Does it really matter how you put it, though?
It doesn't really matter. So here's the deal. When we're trying to find the zeros using algebra, we will come up with an imaginary number if he doesn't have any zeros, right? He's not touching at all. So when we're doing it using algebra, we're going to get an imaginary number. That's why imaginary numbers exist, is because there's no solutions. Right? Does that make sense? Yeah? Yeah? You will grow to like complex numbers, I promise you. Okay. The square root of negative 1 turns into I. Okay? I'm gonna skip example 4 because I don't like it. We're gonna skip example 4. Okay, go to the back side. All right, just a couple more. We'll do example 5, example 6, and then we'll stop. Okay? Because we're going to skip example 7. We're not going to talk about the conjugate. Okay? So example 5, example 6, and then we're going to stop. Now, the beautiful thing about i's is that other than the fact that when you're simplifying, it's negative 1, the square root of negative 1, i's are treated just like x's or y's or anything else, right? Okay? So when you're adding, i's can add to other i's. I squareds can add to other I squareds. Numbers can add to other numbers, right? Okay, so we have 5 minus 7i plus 2 plus 4i. Okay, so we need to combine like terms and put together. I'm sorry, it's going. Okay, so we need to combine things. So what numbers can you combine? 5 and 2, which makes 7. And now those are done. 5 plus 2 is 7. 7. Sorry, I don't know what's going on with it. I don't know why it's doing that. Okay, there he goes. We're just really delayed right now. So, 5 and 2 add together to make 7. Okay, now, can the 7i and the 4i go together? You betcha. But this is negative 7i and positive 4i, which is negative 3i. And that is all, folks. Wow, that's a lot.
That's it?
That's it.
Why can't I all do like that?
Okay, that's it. Yeah, they're not bad. Okay, now, B is subtracting. Make a little note of this guy. Subtract. Okay? And anytime you're subtracting, you need to be very, very, very careful because this negative makes not only the 3 negative, but also this second one negative. And since the second one's already negative, you're going to turn it positive, right? Okay? So I'm going to rewrite this without the parentheses. I'm going to rewrite this total thing. 4 minus 8i is not going to change. But then the 3 is going to become negative 3. And then what? Plus 6i. So anytime you have subtract, put a little star right there because you need to distribute the negative, right? Okay, that's the thing that you do. All right, so now I'm going to combine. So what can I combine?
The 4 and the negative 3.
4 minus 3 is?
I don't know.
1. Those go away. Okay.
And then
1
you
minus
combine
2i.
Negative 8i
6i.
and 6i.
Negative 2i.
That's it. Okay. I's you treat just like x's or y's or z's or any other variable, right? Okay, last one. An AC circuit. In an AC circuit, the voltage, current, and impedance are related by the formula. Voltage equals circuit times, or current, current times impedance. Find the voltage. So we're trying to find V. They say the current is 2 plus 4i, and the impedance is 9 minus 3i. So current, we have to take current. Current is this guy, 2 plus 4i. And what are we doing with the I, with the impedance? What does this thing say? You're multiplying. So I'm going to put just them right next to each other. 9 minus 3i. Okay? You see this? We're just multiplying them together. They just gave us a story problem, whatever. We're just multiplying.
So then you take 2
Okay,
times
so how do we do this?
You
What's the
take
procedure?
2 times 9.
Just wait, what is it called?
No.
No, what's it called? Well, it's kind of like distribute.
It's
Nope.
that name thing.
What's the name thing? 8th period shouting at you right now because they know the name of this. What is it called?
Don't know.
When you have 2 binomials times each other.
A trinomial.
No. It will be a trinomial, actually. It will be. Right? What's it called? Oh, they're shouting. 8th period. You know this.
Foil.
Foil!
I got it.
Oh my gosh, they got it now.
Right? I got it.
F-O-I-L. Okay,
I was close.
foil, F-O-I-L. We've done foil before. So F stands for first. The first pieces. What are the first pieces?
2 and
2
9.
and 9.
2 and 9. Multiply those together and you
I
get
get 18.
18. That's F.
So you get 18.
The O. The O's
Outside.
are the outsides. So 2 is on the outside. What else is on the outside?
3i.
Negative 3i.
Then you multiply them.
Multiply those together. What's 2 times negative 3i?
I get negative.
No, 12i squared.
Minus 6i.
Negative 6i. 2 times negative 3i is negative
Then
6i.
your inside. So then
Okay.
4i.
I don't know.
Trying to
Then you do the inside. So that was outside.
choose 36i.
Okay. Insides. 4i and 9. 36i. Right there. That's the insides. And the last pieces. 4i and negative 3i. Negative 12i squared. Okay, now here's the weird part. The last thing for multiplication, the weird part, is I know that I is the square root of negative 1, but I don't want any square root of negative 1. So I'm just going to leave those i's there. But I do know that I squared is what?
Negative 1.
Is just negative 1. So I'm going to replace him.
Plus 12.
So that 12, instead of being negative 12, he's going to become
Positive.
positive 12. So this guy is plus 12. Now I'm going to combine. Now I'm going to combine things. Okay? So what can be combined? 18 and 12 makes 30. And then I can combine the negative 6 and 36i plus 30i. And that is all. Okay? So if you have an I squared, go ahead and simplify him.
Wait, why is that not
What?
Why is that not
What do you mean?
Why isn't it there?
What? Why isn't what there?
12.
Because we added the 12 to the 18.
Oh.
Right, to make 30. Yes, yes. And we
Oh,
combine these
okay.
little pieces up. Okay? Alright? But there's no I squared anymore. So you're into negative 1. Good, good? Yes, yes. All right. So 8th period.
We're the favorite. Don't forget.
They're the favorite. Don't forget. Whatever. So go ahead and I have a homework assignment posted on Google Classroom. So do that.
Oh, shoot, we have to remember all
Why
that.
on Google
It's
Classroom?
right at the end of the day.
Oh shoot, I need to.